Hello everyone, my name is Edmund and I am a student in Professor Cliver's DC Circuits class. And today I'll be going over how to find Thevenin's equivalent circuit from just a regular circuit like this. And there's many ways to approach it, but this is how I would do it. I'm using the organic chemistry tutors circuit, but I'm going to try and use my own words and explain how to find an equivalent circuit. Okay, so the first step in finding an equivalent circuit is to short out all the voltages and open up all the currents. So we can do that here by deleting this, and reconnecting the circuit. And if we want to hand calculate this, we would find the total resistance. So since these two nodes are touching, this resistor and this resistor are in parallel, and that's in series of this, and that would come out to be 11.2 ohms for our Thevenin. We can bring the circuit back to normal, and the next step is to find V Thevenin, the equivalent voltage, and to do that we can use the combination of Kirchhoff's current law and nodal analysis to find our answer. So, nodal analysis, or Kirchhoff's current law, states that the sum of all currents going in must equal 0. And we can use nodal analysis and KCL to help us find this. So we can label this point here, or this node here, as node C. And this node over here, it's just 50 volts. This node here is node B, this is node A, and this node B here has no current because it's ground, so it's 0. So I can write, so the first current will be 50 volts going in, subtract VC, this node over here, over 4 ohms. And this, we add 3 amps because it's 3 amps going in. And the 3 amps will only go through R3 because this resistor isn't connected to anything, so this current won't go into resistor 2. And then this part of the equation, point C, node C, minus 0, this node over here, over R3, which is 5 ohms, equals 0. Next we multiply everything by 20 to get a common denominator. That cancels out the 4 and the 5. So you get 5 times the quantity of 50 minus voltage C plus 60 minus 4 VC equals 0. We can expand and then combine like terms. 250 minus 5 VC plus 60 minus 4 VC equals 0. That equals 310 minus 9 VC equals 0. Move the 9 volts to the other side, divide 310 by 9, and you get 34.4 volts. Then we can make our equivalent circuit like this. So VC is 34.4, sorry. Resistor 1 is 11.2 ohms. And this circuit should be equivalent to this circuit over here.